Okay, valuing the option to abandon. You know, remember we can calculate the market value of project as a sum of the NPV of the project without options, and the value of managerial options is implicit to the project. So we so that market value is equal to NPV plus the value of the options. So we market value is just the value of the project with options. Recall we calculated the NPV without options to a loss of $38.64. So the value is the amount that creates that $75 after the loss of 38.64. So the value of those options is $75 plus $38.64. So the value of the options is $113.64. Okay, so it's an example of an option to delay. So there's a homework problem where you have an option to delay. So in this example, the cost of the project declines from 20,000 down in year zero to 16,760 in year four. The present value doesn't decline, but you have to remember that this is, for example, this 25,000 is in year zero, and this 25,000 is in year four. So we have to present value those back to today. So using a discount rate in this case is 10%. So, but this is the NPV as of year one. I mean year zero, year one, year two, three, and four. So, we look at the project. We can then enter into the project over in any of the next 4 years. Calculate the NPV. By an initial example, it looks like a year four would be the most valuable, but that's going to change when we present value those back to today or year zero. So the $5,000 NPV is worth $5,000. The highest NPV occurs in year two. So as a result, we would select based on this information, we would select year two to enter into the project, so, because it yields the highest NPV. So and to calculate the NPVs in this case, we take that $7,900 and we present value it back 2 years. 1 plus the 10% squared. So that equals our $6,529. The 8240, for example, would be divided by 1.1 to the fourth power, and that would give you $5,628. The final topic for this chapter is decision trees. They allow us to graphically present alternatives available in each period and the consequences or outcomes of our actions. The graphical representation helps you identify the best course of action. So here's an example. So squares represent decisions made. The lines lead away. So you have different options. So in this case, study finance, do not study. And then we have receipt of information, the circles, and then the different outcomes that or decisions that result of the moving away. So, example here, we have a decision tree for Stewart. So we have first decision is test or not test. So then if we test, we come to the point we receive information. So we either have success or failure. So once we have those two, we decide whether we want to invest or do not invest. The, or we can also invest with regard to the failure scenario as well, which ends up with if we invest, we have a net present value benefit of 4.175 billion. Non-invest, the NPV is zero. If we invest and after a failure, the NPV is negative 44 million. So the firm has two decisions to make. First is to test or not test, and then second, invest or not invest. So that is the end of chapter 7.